Everyone, it's April 25th. All right, we have this one. Minimum falling path sum. Given n by n integer matrix, return the minimum sum of a falling path with non-zero shifts. Falling path with non-zero shifts. A falling path with non-zero shifts is a choice of exactly one element from each row of grid, such that no two elements chosen in adjacent rows are in the same column. Falling path with non-zero shifts. So in this case, so if I choose this, the next one I cannot choose 4, I have to choose this. For this, I cannot choose this, but why don't I choose 9? All possible falling paths. Because we want to find the minimum. 9 is the maximum. So yeah, 1, 1, 5, 7, 1, 5, 9, 2, 4, 8. Oh, we can do 1, 6, 7, 1, 6, 8, 2, 4, 8, 2, 4, 9, 2, 6, 8, 2, 6, 7, 3, 5, 3, 4, 8, 3, 4, 9, 3, 5, 7, 3, 5, 9. And the minimum is this. 200. And the value can be negative. Okay. We start from something and then we go to the next one. We have these options. Right, if you think about it, it's just like a graph, right? So the first row I have a cell. In this case, we can do a 3 by 3. So I'm here. So my children can only be this and this. All right. So it's like, in this case, 1 can go to 5, 6, right? And then 2 can go to 5 and no, 2 can go to 4 and 6, right? 2 can go to 4 and 6, and 3 can go to 4 or 5. So each one will have this. Maybe we can just do this, I don't know, BFS, like for first one 1, and I can go to this and this. I push this in, and then for the 2 I can go to these as well. For 3 I can go to these as well. But if I've gone to someone, then I simply just update. Right? Basically we say what is the minimum of reaching this, this, and this, right? Or we can say what's the minimum of reaching this, this, and this. So the minimum of reaching this is now we'll just go top down, right? So we have something like this. To reach the position, right? We have reached the position. So we have a DP table, okay? So DP table is like this. So the minimum to reach these will be 1, 2, 3, right? So I say, okay, now the minimum to reach 4. To find the minimum to reach 4, I just need to say who can reach 4. So I go to, this can reach 4. So I go up, go through the entire thing except the one with the same. I do that, and this is going to be 6. Minimum here is going to be 6. Minimum here is going to be 7. And I'll go here. Minimum with this is going to be the minimum of these two, right? So that's 13. This is going to be minimum of the, except for this, which is just going to be 14. Minimum of this is 15. So the answer is 13. So O(n) squared, Okay, O(n) squared, I think I can get this done. Why don't we just solve this first, and maybe there is a better way for this. Oh, shoot. My bad. So what do? We say, we can just use a grid. That is fine. Then we can say for int I equal to 0, I equal to 1, I smaller than grid length, plus plus. We say for int j equal to, oh, but for every single one, oh, hold on. That is going to time out, because for this, I have to go through this. For this, I have to go through this. For this, I have to go through this. So that will be O(n) tripled, right? O(n) tripled, 200 times 200 times 200. That is not gonna pass. Okay, so we need a better way to find out who is the smallest. Like, not except from your thing, who is the smallest? How do we quickly find that? Right, basically that's what we want. Yeah, you cannot, because we have to go through every single one of them. Alright, so that's already O(n) squared, and for each one we have to go through that. So O(n) tripled. O(n) tripled is not gonna work. O(n) tripled is not going to work. O(n) tripled is not going to work. Okay, so is there a better way to find out the minimum? So basically, for each one, right, except from one of them, like this is the smallest value, right? So like this will use this will use this as well. Only thing that doesn't use this is this. So basically, we can, as we go through, we find the minimum, okay? So as we go through, we find the minimum, record its position, right? We record its position. So everything gets revisited twice, at most twice. Oh, we find the smallest and the second smallest, right? We find the smallest and the second smallest. That's what we wanted. That's what we want. Smallest and second smallest. So basically, for each row, as we go through, we find the smallest and the smallest index, second smallest and the second smallest index. And then as we go through the next row, we check. If the smallest index is not the same, then we use the smallest. If it's the same, we use the second smallest. Yeah, okay. So we're still doing a similar thing, but I need to create two things. I need to create min value, min v. Not just min. We can equal to, I don't know, what's gonna be the 99. So the minimum is gonna be, the maximum is gonna be 99 times 200. So I'm just gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's that. And min index, doesn't matter what it is. And second min, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And min second min index. Okay. So we need to go through the first round for int j equal to, and we're gonna do int n equal to grid dot length, and it's n by n, right? Yeah. Okay, so we're gonna do this. j smaller than n, and then j plus plus. Okay, what we want to do is to find, so we say if grid 0 j, okay, if it's smaller than minimum, okay, then minimum shall equal to grid 0 j, and minimum index shall equal to I. Okay, else if grid 0 j is smaller than second minimum, so it's larger or equal to the first, but it's smaller than the second, then we say second minimum equal to grid 0 j, okay, and second minimum index are equal to I. Oh, j, shoot, j, right? So we go through this. If it's smaller than the smallest, we set it up. Oh, actually, if it's smaller than the smallest, we set it up. And I think we have to do this, right? If it's smaller than the smallest, we set it up. And no, hold on. No. That's not the way. If it's smaller than min, min equal, if it's smaller than min, then we have to also say int temp will equal to min. No. We'll say this. If min is smaller, but of course, right? So basically second min will equal to min, second min index will equal to min index, and then we'll reset these because have something smaller than min, so min become the second min. And if it's not smaller than min, but it's smaller than the second min, then we set a second min. So okay, that's that, right? And then we are going to go from 1 to the length, and for j will equal to 0, j smaller than n, so this one we can actually change. Change that to n, and j plus plus, right? Okay, then we basically said if j is not equal to minimum index, okay, then we say grid ij shall equal to minimum plus equal to minimum, right? Because j is not equal to that, then we just plus equal to minimum. If it is equal to that, then we're gonna do something. Oh, that is because I need to create like a temp. Okay, that's not the right way to do. Okay, let's do this. Min and second min. Okay, so we're gonna be 4, new int 4. 1 2 3 4 5 6 7 8 9 minus 1. 1 2 3 4 5 6 7 8 9 minus 1. Okay, so we can delete these, and for this we can say min and second min equal to min index, second min, and second min index. Okay, and let's basically say min and second min 0 1 2 equal to this. This is min and second min 3. Okay, this is going to min and second min 0, and this is going to be min and second min 1. Okay, here is second min, so this is going to be 2, and this is going to be 3, right? And each time we're gonna say int temp new int 4. That should be good. Okay. Then actually that's that's not good because we want to find. So okay, this 2 3 4 5 6 7 8 9 minus 1 1 2 3 4 5 6 7 8 9 minus 1. Okay. And then this is to get the minimum to reach ij, right? Because I add the minimum if j is not. Else, if j is equal to, then grid ij, we're gonna plus equal to second min, right? Equal to second min. So like if I cannot get a minimum, I get a second minimum because that's the smallest way for me to move on. And once I do that, I need to run the algorithm. We say if grid, there's no min and then there's no second min. Okay, so here is going to be, I think we shall do here is to update. Okay, we say private void update min and second min. Okay, so we'll pass the value in and we'll pass the int min and second min. Okay, and what we do is we'll run this. Okay, we'll run this whole thing. Okay, we'll run this whole thing here. Okay, we'll run this whole thing, and that's not min, that's min and second min 0. And every time you see grid 0, right, and then we j do this. Oh shoot, this is gonna be val, right? If val, then this equal to, this should be min and second min 0. This is min and second min 1. This is val, right? Oh my god, I need a val and index. Right, so we can do index. And here is the same thing. We're gonna do val. And this is val, and this is index. Okay, so once we do that, we can say update val is grid 0 j, index is going to be j, index is going to be j. Okay, then we don't need this, we can delete this. Okay, and here this is good, and we get the grid, and then we call update this again. The value is grid ij, index is going to be j, and this is going to be temp. Okay, so we update because we need to use this value min and second min. This is going to be 0, and this is not min, index is min and second min 1. Here is going to be min and second min. Do I even need the index for the second min? I don't need the index for the second min, so I can just do length 3, right? That's enough. I don't need this part. 3 is enough, right? So we do this equal to this. We don't need this. We need this. We need this. We need this. We don't need index. So we still need index. Okay, index is still necessary for the min, but it's not necessary for the second min. So we do this, that's good. This is gonna be 3. So we're gonna remove this. Okay. This is if j is not equal to, that's correct, then we're gonna do this. Otherwise we're gonna do 2, right? Once we're done, we'll update on a temp, right? We go through everybody, and then once we're done with that, then we get out, we shall say min and second min equal to temp. Okay, equal to temp. And then go back up, blah, blah, blah. No, now once we're done, Okay, we go through everything, then we have min and the second min and the last. So we should return min and the second min 0. Cannot define dimension expression when the array initializes. Oh, really? Oh, okay. I don't know. All right, let's go and test it. Let's see how it goes. Let's run this. I have a second min, my bad. There's no second min. There's only min and second min 0 and 2, right? It's 2. Try it again. All right, looks good. All right, that looks good. I'm gonna put some documentation for this. Okay, let's go. Yeah, so this is an array of, yeah, just so that I don't mistake this one with an actual code. All right, so this one is going to be 1289 dp, right? And we can use a grep grid as the dp table and change it in place. Okay, and the goal is to compute a dp ij, right, ij, such that it contains the smallest sum ending at smallest sum of a falling path ending at position ij. Now to do so, we need the minimum falling path on the previous row that is not on the same column as the current cell. So we produce a minimum sum and second minimum sum for each row. If the current cell does not fall on the same column as the minimum sum, we always use the minimum sum of the previous row. Otherwise, we use the second minimum min sum, right? And that will done in O(n) squared time. Okay, let's try this, and hopefully this one is correct overall. And it is correct. One of the easier hard problems compared to the one that I've been struggling for sure. I've been struggling on this for quite a while, and then it's still no end in sight. And actually, I don't feel like doing it today. There is a way, but I don't feel like doing it today, so I may do it some other time. Yeah, just kind of complex. I don't feel like doing it. Top-down dynamic. O(n) tripled. O(n) tripled. Same minimum, a second minimum, yeah. Yeah, I think this is a good interview question. I'm gonna put that in my list. Good interview question. Because this has like kind of two levels, right? The first level is always you can do a DP. That's one level, the ON tripled. But then a little bit smarter and just to just see if you can think about it doing another way. All right, okay. So I don't want to do it, but I still want to go through my idea. So yesterday, it turns out that we cannot create the cycles just the way we want. So now we can still create a cycle. So this one still works, okay? Except we don't append it, okay? We do not append. What happens is we'll create a cycle, right? And then we'll start the index from back to the front, okay? Back to the front. So we have index and its value. Index value, index value, index value, index value, all the way to the front, okay? And then what we're gonna do is, and then we record. It's a cycle, right? It's a cycle, so we record which cycle it is, and then not really which cycle it is. It's just the index, right? We have the index, and then we know this index belongs to. I don't even need to know which cycle, right? So it's just a cycle, right? And then we have something that's not part of the cycle, right? And for the one that is a cycle, we can compute, right, from the beginning. So we do the same, compute max score for this one with the cycle, and then once we finish compute, we'll go through the other thing, and then if as we compute every cell, we record the sum, and then we record the but then that's the problem, because you're going backwards, right? You're going backwards. That's the problem. You cannot go backwards. Yeah, I mean, technically you can go backwards, but it will be much harder to go backwards. Now what? Yeah, go backwards is gonna be harder, for sure. Because go forwards, you just in it. Go backwards, you might have to get out of the cycle, and I don't see how we can do that easily. And there might be a way, but I don't see how it can be done easily. So maybe I need some other idea. I still think this idea is right, but the problem is just you have to create a copy of the cycle. That's not working, right? That's not working. Yeah, if we create, like, we have one cycle, that's gonna work. It's just if the second one and then kind of inject itself into the cycle, how we gonna deal with that, right? How are we gonna deal with that? And it's gonna start from here. How are we gonna do? Maybe we can start from the front, right? And then we know it enters the cycle from this position. Then we can compute the rest, because if I do, a prefix sum on that, then I know from here to here how much it is gonna be. Then you're gonna inject yourself in, and I will compute that. I compute that. I know where it is, and then I just move forward. I can go forward. I go forward. I go forward. I go forward. That might actually be working. So basically, we'll still do the same. Okay, we still do the same cycle, but each element in it, I need to know its position in the cycle, right? Need to know its position in the cycle, and I need to know which cycle it belongs to. Okay, so when I attach, right, then I know this one is going to belong to this cycle, and it will have an index, right? It will have an index as well. Okay, what is that index is going to be? It actually can go negative. It's fine. Now all I need to know is just do I even need to know the index? I do need to know the index on the cycle because I need to compute. But I don't really need to know the index. So all I need to know is for this portion, right? For this portion, for this part, and it's gonna insert into a cycle. I need to know which cycle it is, and I get the cycle, and I have a prefix sum for this cycle. Then I know everything about the cycle. Then you go from the start. I know the length, and I know from the start of the cycle how much distance is going to be, so I can do the computation of the sum, and I know that sum, right? So I know the total sum. Then I can move forward, right? I can move forward. Basically, we are going to do this along the way. Each time we find a small piece, we'll compute it, because the cycle will be found first. Okay? I think that is actually going to work, right? All I need to do is to keep each on the cycle, right? On the cycle, I just need to know each element in the cycle, which cycle it belongs to, right? Which cycle it belongs to, and what index in the cycle it belongs to. Those are the only two things I need to know. And then if I have injection, it can be done. Okay? I'm not doing it today, but I think we have a path forward. All right, that will be it for today. I will see you guys tomorrow. Adios.